Good morning, folks. So we are moving into our last section of chapter 4. What that would normally mean under normal circumstances is we are approaching a test. However, I'm going to switch things up a little bit with this. I do want to give a mini quiz on just this section like I have the last few. And then I want to circle back and do some more applications, some word problems dealing with all of the three sections we've covered, 4, 5, 4, 6, 4, 7. So after that word problem review, then I'm going to introduce and talk about what we want to do as in terms of a test for chapter 4. I need to talk to the other Calc CP teachers a little bit about how we're going to handle chapter tests moving forward. But refocusing on chapter 4 or section 4.7, at first look, it is going to be intimidating because it can be information overload. What section 4.7 deals with is a massive list of shortcuts for integrations. So we could literally spend an entire year spending all the different tricks, tools, and calculus to learn how to integrate everything individually. Um, or we could take the shortcut and say, well, people have been doing this for hundreds of years. Let's kind of just look at the formulas that have already been discovered and developed and use that as a reference. And that's kind of what we're going to do for a Calculus CP course. That's what that attachment you should already have open is all about, is here are 26 different formulas to use as references. In each one of these formulas, you're going to notice the variable is always x, but there's lots of different a, b, and n terms that you're seeing mixed throughout these formulas. Those represent either exponents, coefficients, numerical terms. Okay, those are real numbers. Those are not variables. So basically, the trick here is you're going to try and match a given integral that looks like the form of one of those 26 that are on the reference sheet. Once you match it, it becomes a very straightforward substitution into what the antiderivative is. And we're going to see a few examples of that in this video, and I'm going to do a few more tomorrow, just not to overwhelm you in any one day. So again, make sure you have that reference sheet with you. So it should have all of these slides. I'm going to click through it really quickly because you should already be looking at these. So here's our first one. Evaluate the antiderivative dx over x quantity 3 minus x. So hit pause, try to find one of those 26 that most resemble this, and then unpause. So hopefully when you're looking through this, it's not ever going to be a perfect match, keep in mind, because A and B are going to be any real number possible. But if you're looking at line 20 in the formula, that is the closest that we have to this integral. It's 1 over x, ax plus b. Keep in mind, a can be any real number. So what we have here is my ax, the a coefficient, is matching the -1 coefficient on x here. The plus b, they just rearranged terms, is going to be 3 here. So a is -1, b is 3, everything else kind of matches this form here. So we're going to just plug a and b into the terms here for my antiderivative. And that's where you see this 1/3 natural log of x over -x plus 3 with your constant of integration c. Okay? It's definitely not the most simplified, or excuse me, not simplified. It's not the most straightforward antiderivative, but it's a lot faster using this reference sheet than what we would have had to do developing this with our skills. So, example number 2. Again, take a look at the integral. Your first task is going to be which of the 26 formulas best match this integral. Keep in mind, coefficients are allowed to be moved around here. So if something doesn't match perfectly, maybe you can factor a coefficient in front of the integral. So hit pause, try and find a formula that matches this one and then unpause. So this formula fits 19 table or formula 19 in your table, except notice that in the formula for 19, the numerator is just x, okay? Which I kind of hinted at that earlier. This 2 is a coefficient. We can pull that 2 in front of the integral, and then it would be 2 times the integral of x over 3 minus 5x quantity squared. So that 2 is not, the fact that this doesn't have a coefficient is kind of irrelevant because we're allowed to pull those 2 out and then it matches the form. So the a and the b here that you see in your antiderivatives, well, a is going to be the -5, your coefficient on x, and b is the 3 that we're adding inside of that squared quantity here. So if a is -5 and b is 3, we can plug into this antiderivative here. Now, the PowerPoint from the book is referencing that they factor the 2 out. They didn't really show that well. They do it better in the next example. But what they do is they just take this entire formula. After they plug in your b term is 3 and your a term is -5, they multiply that 2 to every term in the antiderivative. And then the very last thing you need to do is just simplify all these numerical terms. You wouldn't want to leave a -5 squared when you can make it a 25. Okay? So again, I can anticipate there's going to be a little bit of confusion at first with these, but I promise you, I'm not expecting you to have these memorized. I'm not expecting you to be quick with recognizing exactly like, oh my gosh, that's clearly Formula 19. That's not an expectation. This is going to take some time to go down your list and actually say, oh, that's the one that matches, or that's the one I can do a little bit of work with factoring a number, and then it matches. Okay, so take your time. This is meant to be a little bit of kind of a matching game, so to speak. Okay, I want to do one more and then we'll call it a day for the PowerPoint. So again, we have an integral. This one's going to match one of the formulas. And again, take note, you're allowed to factor out a numerical coefficient out of all terms or out of just numerator term if need be. So hit pause, find a match, and unpause. So this one, again, we're going to take that coefficient of 5 and factor out the 5, because if you do that, factoring out the 5 leaves me an x over 7x minus 8. That matches formula 18 on our list. Okay, and 18 is just, again, 1x over ax plus b. If they were going to allow a different numerical coefficient than just 1, they would have put an a or a b there. Okay, so a in this case is 7, b is going to be -8. This one's a little bit nicer because everything's in the correct order. Okay, and again, you're simply plugging all of these into your antiderivative. Once you identify a and b, plug them in. Keep in mind, we're taking that 5, though, in the original integral, and they factor the 5 out so it fits. So inside these brackets are what you're seeing the normal antiderivative be, and then we're going to distribute the 5 through your antiderivative, because that 5 is being multiplied by the integral, so the 5 should be multiplied to the antiderivative. And then it's a simple, very careful simplifying of all your numbers. So you're going to notice in this section, you're going to see some funky fractions here. That's not to be unexpected. So don't panic if you see anything like that. Okay? I'm going to leave it here, and we're going to pick up some more examples of matching these things with the tables tomorrow. Take a look at the homework, begin working on that. There's not going to be an exit ticket today. I just want you kind of practice matching these or manipulating them until they match the antiderivatives. Good luck. As always, reach out with any questions or concerns you might have.